So if you could please take out that chapter 7. We are on page 19. And as I said, we're going to look at some properties of logs today. And these are just properties of logs, logarithms. And there are 3 properties that we're going to talk about. These 3 properties are very similar to the properties of exponents. And that's because logs and exponents are inverse operations. So thinking about an exponent and those properties are going to be similar to the properties for logs. So the first one is the product property. And on the side here, I'm just going to remind you of that exponent property. So the exponent property would say a to the x times a to the y. That's product. When you add them, you combine your exponents. That's the product property for exponents. So if I have a to the x times a to the y, that's equal to a to the x plus y. So that's the exponential property. The log property says the log base b, and I'm going to use m times n. So I have a product. That is equal to log base b of m. I'm going to make this a little smaller over here. Plus the log base b of n. So you can see how the 2 properties are related to each other. So the product property for logs can be written as the log base b of m plus the log base b of n. So it's kind of the opposite, and they should be because they're inverses. So Ava R, if we have the log of 4x, how could I write that with the product property?
Would it be the log of 4 as the base, or no?
So if the base isn't there, what's implied?
Oh, it's
to be there?
10.
It's 10, yeah. So we have the little 10 down here. So the
Equal.
log, and then it's going to become addition. So the 4 is like your m, the x is like your n.
Oh, so then it'd be log x.
There you go. And if you want to write the 10, you can, but you don't have to. So that's the product property. So it's being multiplied right now, but we actually separate it into 2 separate additions of 2 log functions. So the product property, I separate it into 2 things being added together. Whereas with exponents, we combine them together with 2 things being added together. So separately, they were being multiplied, but when we combine them, they were being added. And that's the whole inverse. So they're kind of opposites. So let's think about the quotient property. So the quotient property for exponents said a to the x divided by a to the y is a to the x minus y. So that's the quotient property for exponents. The quotient property for logs says log to the m divided by n, and I'll put a little base b. That just means the base can be anything. Oh, there we go. So using my property similar to exponents, when we divide, we are really subtracting. So log base b of m divided by n can be, we call it expanded into log base b of m minus log base b of n. So Brooke, if you look at the example underneath, we have the log of x divided by 2. So how could we rewrite that, Brooke?
It would be log of x minus log of 2.
Yeah, that's it. Log of x minus log of 2. That's it. So the last property that we are looking at is the power property. And that's when we had a to the x to the power of y. And we multiplied the exponents together. We took x times y. So as a log, we have log base b of m to the power of n. This still becomes multiplication, but that exponent is going to travel in front and become multiplication in front of the log. So it's going to be n times the log base b of m. Or maybe we'll put parentheses around this to make it look a little better. So it's multiplication, but the exponent moves in front of the whole log to become multiplication. So looking at the last example, we have the log of x cubed. So this becomes 3 times the log of x. So the exponent moves and becomes multiplication. So we're going to try and apply these properties, and trying to start with example 1 here. Example 1 gives us numerical values for the log of 4 with a base of 5 and the log of 9 with a base of 5. We're going to ignore that for right now. I want you to just try and apply the property to letter A. So looking at letter A, we have the log base 5 of 4/9. So see if you can apply the property that corresponds with letter A. So think about, what are you given? How would the log property apply to it? So Ella, how would that log property apply to the log base 5 of 4/9?
You would do log base 5 4 minus log base 5 9.
Yeah. So it's a quotient. You make it division. So the division bar, I'm sorry, you make it subtraction, becomes subtraction. And now we're going to evaluate. So now that I have these two separate logs, we know that the log base 5 of 4 is 0.861. So we're going to replace with 0.861. So this is kind of the way of getting around you using your calculator. We also know that the log base 5 of 9 is 1.365. So to evaluate this, we just need to subtract those two numbers. And I guess you could use the calculator here. I think you could do some mental math as well. Ella, can you subtract those two numbers? If you have a calculator, you can use it. 0.861 minus 1.365.
I got negative 0.504.
Yeah, nice job. All right, so that wasn't so bad. So let's look at letter B. So letter B, we have the log base 5 of 36. Now, our goal is to take that 36 and rewrite it or change it. And we want to change it so that we have the numbers 4 and 9, because we're going to try and use the numbers they give us in the problem. So Faith, how could we rewrite 36?
You could do
What two numbers multiply together to be 36?
6 and 6.
6 and 6. What else multiplies to be 36?
4 and 9.
4 times 9. So if we write it as log base 5 of 4 times 9, Faith, how could we then use one of the properties above to rewrite the log base 5 of 4 times 9?
You could do log base 5 to the log base 5, 4
Mm-hmm.
plus log base 5, 9.
Perfect. Yeah. So we rewrote 36 by making it 4 times 9. And then I can separate that into the two individual logs. And then we would have 0.861 plus 1.365. And Faith, if you add those two numbers together, what do you end up getting?
2.226.
Yeah, nice job. Good. All right, the last one on here. So we have the log base 5 of 81. So I want you to think, what's a different way that you can write 81? So how else could I write 81?
9 squared.
9 squared. Thanks, Gabby. So we have the log base 5 of 9 squared. So Gabby Soul, how do you think you could change that one using one of the properties above?
You would bring this squared and just put the 2 in front of the log.
Excellent. So that's the product property. And then using our information above, we have 2 times 1.365. And Gabby, do you know what 2 times 1.365 is?
It is 2.73.
Awesome. Nice job. Excellent. Any questions on those? So we're trying to rewrite the given value, and then after we rewrite it, we're trying to apply those properties of the logarithms. Questions? So we're going to continue working with trying to apply these properties. And instead of working with a numerical base, we're going to now work with variables. So if you look at these 4 problems, they look a little involved because we have a couple of variables in the problem and a numerical number as well. It says to expand the following logarithmic expression. So when you're expanding it, you're using these properties of logs. So you're taking the multiplication, you're splitting it into addition. You're taking the division, you're splitting it into subtraction. So we're making it into multiple logarithms. So if you look at part A, I'll walk you through this first one just so you can kind of see how it's going to work. The first thing, notice that it's division. So I have something on top divided by the y on the bottom. Division means the property should be expanded into subtraction. So we have the log base 3 of 7x squared. The division symbol, think of that as changing to subtraction when we have properties of logs. And then log base 3 of y. So the numerator becomes 1 log, the denominator becomes another log. Now we still have to look to see if we have other operations. And this first log is multiplication because it's still 7 times x squared. Well, multiplication gets expanded into an addition of 2 logs. So that first log becomes log base 3 of 7 plus log base 3 of x squared. Because it was a product, and a product can be expanded into addition. And then we still have minus log base 3 of y. So there's still one more step here. If you look at the middle expression has an x squared, and that's the third property. That's the power property. So to finalize this, I would have the log base 3 of 7. That power gets moved to multiplication, and it makes 2 times the log base 3 of x, and then minus the log base 3 of y. So we took it step by step. First, the division sign separated it into a subtraction of 2 logs. The second step, the product becomes addition of 2 logs. And then the last step, the exponent becomes multiplication of only the log that it's attached to. Questions? All right, so if you look at B, it's similar to A. See if you can expand B. So the log base 6, 5x cubed over y. So very similar. Try and expand B. And Jordan, I'm going to come to you in a minute. And we're going to do letter D as well. I think I'll skip part C, but we'll look at letter D. So if you want to do letter D after you do B, you can try that one as well. All right, Jordan, let's see how you did with B. What would you do first?
First, I did log base 6, 5x cubed minus log base 6y.
Good. And then what's next?
Log base 6, 5 plus log base 6 x cubed minus log base 6y.
Excellent. And then your final expanded expression.
Log base 6, 5 plus 3 log base 6 x and minus log base 6 y.
Yeah, it's a mouthful, huh? Nice job.
Yeah.
Good. Excellent. All right. So as I said, we're going to look at letter D. Ava M., do you think you could try letter D?
Yeah, so first I did expanded it into log and then the cube root of x
Okay.
and then minus log y to the 4th.
Perfect. All right. What'd you do next?
I'm not really sure, but would you have to like go to the 3rd power for each of them?
You
Multiply?
are so close. If you have a cube root, what exponent would be a cube root? It was a fraction. I'll give you a hint.
Is it 1/3?
It is 1/3. So we can make this x to the 1/3. And then what would you do with those 2 exponents, Ava?
You'd put them in front, so it'd be 1/3 log x minus 4 log y.
Nice job. Very nice. Good. Anyone have questions? Good. So if you look at the group underneath, it says to condense. So condense is exactly the opposite. So we're just trying to do the opposite now. It's in expanded form. Can we pull it back together into its log form? So the log of a single quantity, which if you look above, we expanded, our original problem was condensed. So we're just trying to do the opposite here. When you condense, you're going to move pretty much in the opposite direction. So the first thing that you want to do is look to see if any number is being multiplied. That value should be written as an exponent. So looking at the middle log, the 3, we want to move in exponent form first. So Gabby Snyder, what is 3 cubed?
27.
Yeah, so we're going to make this 27. So we're going to move the 3 first so that it's an exponent. So I'm just going to cross that off. All right, Gabby Snyder, if I move from left to right, because that's how order of operations are supposed to go, the first pair on the left, say addition, how would you condense them? So if I'm adding and I want to pull them back together, what do you think you'd do with the 2 and 27?
Would you multiply them together?
Yeah, what is 2 times 27?
Uh, 54.
Good. All right, Gabby. So now we have the log of 54 minus the log of 9. What do you think you do with those two?
Would you divide them?
Yeah, what is 54 divided by 9?
6.
Excellent. Nice job. So in order to get the 54, we really took 2 times 27. I didn't write that step down, but we condensed them together by multiplying. And then to get log 6, we took 54 divided by 9. So you're doing exactly the opposite that we did above. So let's look at letter B. Helene, what do you think you do first with letter B? Annabelle, do you think you could help out? What would you do first with letter B?
Would you condense the one that's being multiplied?
So what is that going to become?
ln 3 plus ln to the 2x. I mean,
So
2x.
how about x squared?
Squared?
Yeah. And then minus ln y. So what would you do next, Annabelle? Let's look from left to right. So what would we do with the pair on the left?
You would multiply?
Yeah. So that becomes 3x squared. And then the last step, Annabelle, if I have subtraction, how could I condense them together?
You would divide?
Yeah, so you have one ln, and then you're dividing the two terms after the ln. So you would have 3x squared divided by y. Remember, condensing means you're pulling the ln together as one. You're dividing the expression after the ln. So 3x squared divided by y. Questions? All right, so let's just try one more of these. I guess we'll just do letter C here. It's the same with ln as it is with the log. So the first thing, I would make it 3 squared. So ln 18 minus ln 9 plus ln 4. Moving left to right, that's the key. You must go left to right. That's how you read a book. That's how you do addition and subtraction, from left to right. So we're taking the natural log, 18 divided by 9. Subtraction condenses into division, so that makes 2. And now the last two are addition, so I would multiply and I get 8. Are there questions on that? So the very last thing that I want to show you is called the change of base formula. And it looks crazy and big and more than it really is. So it has a bunch of variables here. It has an A, B, and a C. Essentially, what the change of base formula does is it enables us to evaluate logarithms by using a calculator. So this would be evaluating those that we cannot solve for without a calculator. And it takes the log of the value divided by the log of the base. Now, lucky for you, your calculator has this already embedded in its function. So if you look at letter A below, we have the log of base 6 of 11. So this is really saying we're going to take the log of 11 divided by the log of 6. except our calculator already has this in it. So when you go to your calculator, you're going to hit the math button on the left side, which is under the green alpha. So I want you to hit that math button. And if you arrow down, you might have to arrow down further than mine because your screen is a little smaller. But there is, let me pull it back up, log base, and it's A. So it goes through the numbers 1 through 9 and then 0. And then underneath that, it says log base. So again, I'm going to say what I did again. I hit the math button, which is on the left of the calculator screen. Underneath the alpha, the green alpha. So, and then I'm going down to where it says log base. If you type that in, your calculator now is in the logarithmic form. So I can type in anything into this calculator using this function. So my base was 6, my number was 11. And I can type both of those in. And when you hit enter, I get 1.338. What the calculator is doing to calculate that is it's taking the log of 11 divided by the log of 6. And I just want to show you how it truly does work. So if I just hit the regular old log button that we've been using, divided by the log of the base, I get 1.338. So it's called the change of base formula because you are making the base the common log, and you're taking the log of the big number divided by the log of the base. So we are going to end at that point. Most of the homework is working on condensing and expanding, and it's multiples of 3. So make sure you're doing multiples of 3 when you're looking at the homework, and not the odds or not the evens, but the multiples of 3 from 3 to 60. At the beginning of class, we're going to have a very short quiz tomorrow on just transforming from exponent to log to exponent form. So short little quiz at the beginning of class. If you have any questions, feel free to remain on. Otherwise, have a fantastic Wednesday. Please make sure you get out at some point today. Maybe you have a porch that has a roof on it that you can kind of shade yourself so that you can zoom outside. But have a fantastic day.
Thank you. Have a great day.
Thanks, you too.